Thanks for the homework. It gets you thinking. That's what actually along this line.
How many people looked at the homework? Is it a little bit? It's gonna start getting a little bit challenging, you know. So, but you guys are gonna have fun with it. So I think I'm gonna call Charles in a bit. He told me he was gonna run in late, so there's something going on his end. So, but if he doesn't show up, I'll just carry on with the class. It's fine. But again, he has prepared his notes and all that, so I might be using his notes to teach. And even if I'm not that effective, but I think networking is networking. It will still be the same.
Right, you're good. You're good.
So,
You're a good teacher.
so what I was saying, Ola, is okay. Your default gateway, it's think of it like a channel that network packets use to go in and out of your network. So, and the default gateway at home in any network will be the router, right? And your router is a device in your network. It also deserves its own unique IP address, right? So the default gateway IP is the IP address of your router. But the default gateway itself is a channel for traffic to go in and out of your network. That's the difference. And when traffic leaves your network with the help of network address translation, your local IP gets translated to your public IP to be used to communicate with the wide area network. And when traffic comes back into your network, it uses your public IP to come into your network, and then network address translation translates again, and then it goes through the default gateway to the device that was requesting traffic from the wide area network. Does that make sense?
Yes, totally. I'm looking at it in the reverse now. So when we ping Facebook and the other places, the address we are saying is their own that server's public IP address, correct?
Yes.
Okay. Okay. That I completely understand now. Thanks a lot, Gerald. The other question I have is I was looking at the hypervisors. I don't know if that's the right pronunciation.
Hypervisor. Yeah, that's correct.
Yep. So if we are trying to create those hypervisors, their job is for us to both view and create virtual machines. But the way I was reading it, and I might have been misinterpreting it, was it's like it's allocating space from a big system to the hypervisors is the host system. Then you can allocate some hardware space from that host system to guest systems, and those would be the virtual machines on those guest systems. Am I interpreting that correctly?
Okay, so the hypervisor, any system that is used to create any software that is used to create a virtual environment is regarded as a hypervisor. And if you read extensively into hypervisors, you find out there are two types of hypervisors. You have operating system hypervisors, otherwise known as bare metal hypervisors. And a bare metal hypervisor would be like taking an operating system and installing it on the hardware itself. Like, think of it like you installing Windows 10 or you're installing Linux on a machine. So the hypervisor software will be the operating system on that machine. That is known as a bare metal. It means you are installing it directly on the system. Like you're installing an operating system. So that's what is known as a bare metal hypervisor. But you have other hypervisors that are known as hosted hypervisors, which an example of a hosted hypervisor is Oracle VirtualBox. Most of the ones that I told you guys to download and install, VMware Player, VMware Workstation, those ones are not operating system. Those ones are applications that you install the application on your machine, and your machine already got an operating system. You already have Windows operating system running on your machine, right? So the hypervisor you're going to install, it's not going to be the operating system. It's just going to be an application on your operating system, which will be used to virtualize, to create a virtual environment. So that's the difference between the two different types of hypervisors. But I want you guys to take note because this is very important. Even though we're going to be using Oracle VirtualBox, we're going to be using VMware Workstation Pro 15, VMware Player. Like I said, those are application-based hypervisors. At work, you're not going to find those types of hypervisors. You're not going to come across VMware Player at work. You're not going to see Oracle VirtualBox at work. So when you guys start interviewing, please, that's one thing I need to let you know right now. You're not going to talk about Oracle VirtualBox. Don't talk about VMware Workstation, because these are free hypervisors that we are using. But in a work environment, hypervisors are not cheap because they'll be using VMware itself. VMware Workstation is an application. VMware itself is a software. Like, you have people that actually enroll into that course to learn virtualization. People learn VMware and become VMware experts. So at work, you'll be most likely using VMware to do any kind of virtualization. If you have a Windows 10 Pro operating system on your machine, Windows 10 Pro operating system comes with an inbuilt hypervisor known as Hyper-V. Hyper-V is also used to do virtualization. Some environments, some enterprises also make use of Hyper-V. I have Hyper-V on my machine. Hyper-V is an acceptable hypervisor to use. I've seen it in enterprises, but you won't see Oracle VirtualBox, you won't see VMware Player. So those are the ones you will not mention in your resume, because they're going to be like, you're saying you have 3-4 years of experience and you're talking about Oracle VirtualBox. Which environment uses Oracle VirtualBox, right? So you don't want to talk about them. So you'll be talking about using VMware EXSI6 or using KVM or using Hyper-V, things like that. So the reason I'm having you guys use the applications is because VMware itself is expensive. If I tell you guys we're all gonna spend $1,500 to get VMware software added to what you guys are paying, you guys have been like, oh, I'm done with this class, right? So we don't want to do that. So we're gonna use the application-based hypervisors to do to do virtualization. But the concept doesn't change, even if you are using the application or you are using the operating system hypervisor itself. They're all gonna virtualize the same. So you can comfortably say you've used VMware, even though you've used VMware Player. They'll work the same. Nothing is gonna change. I just want to clarify that. But Ola, to your question, the resources that are provisioned to the host, right? They come from the machine that the hypervisor gets installed on. So so the host is where the hypervisor is installed on, and then the virtual machines that you build on the host are known as the guest systems. So just give me a second. Okay, my mouse is kind of frozen. Okay, it's got in. Okay, so the virtual systems that are built in the hypervisor are known as the guest systems, the virtual guest. And they're gonna get their resources from the machine that the hypervisor is installed on. Which means if the hypervisor is installed on your Windows 10 laptop, it's gonna get the resources from there. And when I say resources, I'm talking about CPU, memory, and RAM. But here's the thing with a virtual machine. When you have these guest systems, in the VirtualBox or in the VMware environment, the guest systems, they don't know that they are guests. They kind of operate as if they are independent systems in a way, right? To them, they are a full-blown machine. They don't have the feeling, or it doesn't occur as if they are guest systems, because they operate like a fully functional virtual machine. And they don't feel as though they are competing for resources from the main system. That's the whole concept behind the virtualization. Even though they are getting the resources from the main system that they are hosted on, it doesn't feel like that to them. They feel like fully blown virtual machines that they have all the resources they need to run. So if you don't have the capacity to provision these resources to these virtual machines, then at some point your virtual machines will not be able to run. Because like I said, they are getting their resources from your local system.
That brings me to my one other question, and I can refer this question till Wednesday if I'm taking people's time. I'm just
No,
using.
I mean, we're learning. It's fine.
Yes.
It's never an odd question.
So if that's the case, one of the other questions I had was, that means the computer that we use for hypervisors in companies and big companies they won't be the regular computers we have right now. They'll be like having 2,000 gigabytes of space and whatnot.
That's why we said, okay, that's why we said we are dealing with servers. What is a server? I showed you a picture, a video of a data center, and I told you go watch a video of a data center. Those machines are super machines.
So there'll be data centers with servers installed on them, or hypervisors will be installed on the server.
No, I'm not saying that all hypervisors should be running on data centers. I'm just saying that a server itself is not a normal machine. It's not like a server will not run like your laptop. And I did go as far to explain that a server will not have one power supply. You have like 3 power supplies. You have like maybe 10 cores of CPU. You have like tons of maybe 100 gigabytes of RAM. It will not be a normal machine, right? It's a supercomputer that can run, like, just to let you know, servers can run for like one whole year without stopping, without even booting up, without a restart. That's how powerful they are. But try running your Windows machine at home. Try leaving your laptop for say 1 month or 2 months without rebooting. See what happens. It starts acting up, right? So that's the difference between a normal machine and a server. That's why servers are not cheap. They are expensive. They have tons and tons of storage, tons and tons of RAM, superpower. They have multiple power supplies, fan models, CPU models, to make them have the ability to be able to withstand. You want to do virtualization, you want to do anything with them, they have the power to do that. And that's why they are known as servers, because they cannot stop. They have to keep serving. They cannot go down. So they'll build them with that capacity. And you can keep extending the capabilities of your server. You can have, actually, I used to have one here myself. Yeah. Let me see if I still have it. Yep. Yep, I have a small server here. I don't know if you guys can see it. I know it's a Dell RO750. Since I left Boston, I haven't set it up, but at some point I'll have to set up the server again. I got this one like $800, and it also got like multiple capabilities. Like, I've even forgot. I cannot remember the exact specs of the machine, but it has like maybe 50 gigs of RAM and all that. So that's what servers are built for, to withstand all this extra stuff that a normal computer will not have. So the take home here is your resources that you provision to the virtual machine are going to come from your is going to come from the underlying hardware that the hypervisor is installed on. Does that make sense?
Yes. Thanks a lot, Gerard. I think that's all the questions I have.
All right. Any other question from anybody else?
Yes, sir.
Just give 1 second. Charles is calling. Okay. I'm sorry for the little break. Thank you guys for your patience. So, Professor Charles said he's going to be jumping in the next 30 minutes, in the next half an hour, and he's told me I wanted to proceed. He said he understands his notes better, and I should halt and clearly and just take the opportunity to go through any concept with you guys that so far no one. If you don't understand any concept so far, now will be a moment, and we can also start going through possible interview questions.
In that case, what's a loopback address?
It's part of your homework. I'm not going to tell you that one. I can tell you it's 120. I can tell you it's 127.0.0.1. But what it means, you have to find out.
And then good morning, everyone.
Good morning, Bila.
Yes, last night I was struggling to download the Windows Server 2012 and 16. I was unable. So I'm just throwing it out there if somebody could like kind of help me out, guide me through it. I even watched some of the YouTube video, but it wasn't really that helpful. So I was unable to do that.
Can you tell me exactly the kind of problem you faced?
Like to find a free download, because whenever I type, if let's say I go on Google, I got on Google, I put like Windows Servers 2012 free download or download, I will open a web page.
Okay.
From there, it will take me to another web browser.
Okay.
And then if I try to look it on there, it's kind of like showing me where to pay charges or stuff like that.
Okay. So like I said, I did mention it a little bit yesterday. The Windows Server ISO is owned by Microsoft. Okay. If it's not taking you to the Microsoft website, then it's not taking you to the right place.
Yes, it did, but it was about
it needs to take you to the Microsoft website. Then they're gonna tell you to fill a form. Like I said, they might ask you your name, they might ask your company, and I said you could come up with any name or any company and put it there. Just fill out that information, and then they're gonna let you begin the download process. And then at some point they'll ask you if you're downloading an ISO or for Microsoft Azure image. You have to make sure you select DVD ISO. That's the one they're gonna allow you to download on your machine, and it is free for I think 80 days. So you can use it for 80 days free, and after that they might want you to start paying, right? But yes. 80 days is enough for us, right? You don't need it for more than 80 days. What I want to teach you, you don't need 80 days to learn it. I think 80 days is how many months? Like 4 months, So you can download it, and if it expires, you can create another email, go download again and use it again, build it and build another machine with it and use it again for another 80 days. So if you're still having problems, I'll find the video and send to you. But once it takes you to the Microsoft website, there's no way you're not going to download it.
Yeah, because okay, after class I'll try to work on it again, because like right now I'm on it, it's showing like $150 like add-on card or stuff like that.
Okay.
On the Microsoft website.
Was anyone able? Ola, did anyone else try to do it? Jonathan, Jarvis?
I didn't download it, but I got it's 180 days free.
Yes,
I'll send you the link right now.
Okay.
Yeah,
share the link on Slack.
Okay.
Thank you.
Okay. So okay, let's go over some possible interview questions, and I will share my screen and where's the Slack? Let me go to the whiteboard. Okay. Okay. So let's have some fun, right? So we want to create a local area network, right? And so if we are building a local area network, let's say Faith, you are the architect. You've been hired as a systems administrator, and they're trying to set up their local area network for an office or an office space. And using your networking knowledge, we are putting together the equipment to build the local area network. So what are we starting with? We are doing the design right now.
The internet?
I
said the internet.
No.
Your ISP.
yeah, forget about ISP for now, right? Let's try to look at it like
Okay,
within
so
the
start with
local
your
area
laptop,
network.
your computer.
Okay.
Okay, your computer, your laptop, desktop,
Okay. So
your
let's do
your router.
Yeah, that's where you should start. Before you say laptop, the design should start. You started in the right path with the ISP, and then the ISP. The next thing I expected you to say the router before flying all the way to laptop, because you cannot say, let me have my laptop first before I'm thinking about ISP or I'm thinking about my router, right? So you have the building first. That's where it starts. Like, okay, this is the office space, right? And after the office space, you secure an ISP. What kind of ISP? And this is important. You will never have one ISP in a working environment. There is always plan for disaster recovery or backups, something called redundancy or fault tolerance, which means in most environments you go to, they will have either Spectrum, and on the other side, they have Verizon as their backup, or they have Verizon and have Comcast. You will never see just one ISP, because if that ISP goes down, it means they'll not be able to work that day, right? If Comcast says, hey, we have an issue and one of our routers that is supplying internet to this neighborhood is failed, that entirely means that, hey, until they bring up that router, the office can function. So most businesses will plan for disaster recovery where they have two ISPs, but one will be the standby, and then the one and the other be the main internet supplier for that office. See, so you guys should take note of that. There's never one ISP. Okay, so let's start with our ISP here. ISP, forgive my writing. I've never been the best at writing. You know, so let's see ISP. Your ISP will fall under what kind of network? Jonathan, you're muted.
Local area network.
Your ISP cannot be local area network.
No. Wide area network.
Okay, sure.
I'm sorry.
Thank you. Thank you. You know this thing. Why are you giving me a headache this morning? All right.
Please forgive.
Okay, so this is your one here. Okay. And so then let's see everything from here. This is your local area network in this box, right? So this is your local area network. So we have our connection. We subscribed. Let's say our ISP is Comcast, for example, or Verizon, and the internet connection will come into our LAN. What are the various ways that the internet connection can come into our LAN? Cesar, give it a shot.
Star?
No, I'm not talking about topologies. Like,
Oh, okay.
I'm talking about the various ways that the internet can come into your LAN. Like, use your home like an example. Even though we're talking about an office space right now, what are the various ways that if you subscribe to Verizon, how are they going to bring internet to your house? That's what I'm asking right now.
Through the router or modem.
Yeah, but that is not what I'm. Of course, there's going to be a router somewhere, but based on what we've learned,
You're talking about like coming to install it?
no, they're coming to install it, but
start with the phone line. So without the phone line, you can't have the internet.
No, you use a fiber optic cable.
Okay. That's what I wanted to hear. Like, okay, there are various means that you can get the internet connection. You can get it through fiber optic, right? You can get it through just Wi-Fi, or you can get it through a wired connection, right? And we discuss all those things, and we even went as far as talking about their ranges. What is the range for fiber optic? What is the range for Ethernet? So normally what you have at home is Ethernet. We discuss Ethernet, right? Right? So you're gonna have an Ethernet connection coming from your ISP, and they're gonna use a coaxial cable to connect to the building, whatever building that you're living in. You're gonna use a coaxial cable to connect to that building, and that coaxial cable actually carries analog signal that is gonna attach to what? That is gonna attach to your modem. So the first device here is gonna be a modem, right? So this one is gonna be Ethernet, unless you are super rich that you can afford fiber optic technology, right? If you have that kind of money to afford fiber, then oh, that's good. You can use fiber. But let's just say this is Ethernet. But at work, it is a high probability that this connection coming here is fiber, because those people have the money. Those corporations, they have the money. So this will either be fiber or Ethernet. So either fiber or Ethernet. So take note of that. Now, this connects to your modem. And from your modem, what is it connecting to?
The router.
Okay. Connects now to your router. So we are looking at it now, not at the point of view from an office space. We are looking at it from the point of view of an enterprise, right? So expand your horizon right now. We are living out of, so this is the local area network of an office. So it's gonna connect to this router. And this router is gonna be known as the backbone router. Take note of that word, backbone. It's not gonna be a normal router. It's not, let me show you. So I do have a, sorry, there are always gadgets around my house. I don't know if you guys can see. So I have a router in here. You guys just see what it looks like. Since at your house, you mostly have a combo that's a modem and a router. So I do have a Cisco RV260. I don't know if you guys can see it. Is it showing?
No.
No. Your background is filtering it out once it can't see your face.
I don't know why it's not showing up. I think I need to remove the background before.
Yeah, you have to move your background so you can see it.
Yeah, I'll remove it at the end of the class, and then I'll show you this router.
Yeah, we'll finally see your background, the real one.
Yeah, so it's gonna come. It's not gonna come at work. It's not gonna come to one of these devices. I mean, this one I got it for like $400, but a backbone router at work will probably cost in the thousands of dollars. Thousands of dollars. So it's gonna come to the backbone router. That's where everything comes in. And then from the router, the connection keeps going. There's gonna be another device here. What's it gonna be?
Maybe a switch.
Correct. It's gonna be known as the backbone switch. So you have a backbone router and you have a backbone switch. And a backbone switch will be where all the connections, all the wired connections that are, all the machines in this network that are gonna be using wired connections will connect to this switch. So the switch will have multiple ports. Can have about, a backbone switch can have about 100 ports. So you're gonna have all these ports on the switch.
Senior Gerard,
Yes, sir.
so one quick question, please. So the switch, since it's connected to the network, will it also have an IP address?
Yes, the switch, anything that is connected to the network, it's a computer. Every computer device needs an IP. All devices,
even your
all
cell
computer
phones,
devices, even your cell phone.
they
Like
have IP addresses too.
if you know the IP address of your TV, you can ping your TV, it's gonna respond. If your TV is connected to your LAN, you respond. Try it.
Thank you.
Yeah, any device, ping your cell phone. If you know that, if you know how to check the IP of your cell, like if you log into your router, which, let me just deviate for a little bit. Are you using Comcast, Jonathan?
Yes, sir, Comcast.
Okay, so type, go to your browser, web browser, type 10.0.0.1. And what do you see? Yeah,
I see gateway login. Please log in to view and manage your gateway settings.
yes, so that is your router, right?
Oh,
So I believe if I connect to your network right now, I believe, do you have a username and password for that router?
I don't remember.
Okay, I believe it should be the default, and I don't want to hack into your network right now. I will connect and yeah, so that is your router. I mean, after class, I will connect with you and change the password, because I can bet 100% that you still have the default.
Okay.
Yeah, the default settings. And if you log in there, you're gonna see all the devices that are connected to your network and their IP addresses, your TV, the phones, every device at home that your router, which also a DHCP server, has allocated IPs to them. You're gonna see all of those devices, and that's one way to find out the IP address of your TV, and you can ping it. Yeah, and you can go into that router and start making changes. You can say, okay, DHCP, I don't want you to give more than 50. You can cut down the number of addresses you want DHCP to allocate. You know, you can make all those fun changes. You know, everything happens in your router. So back to our Jamboard. So
Quick question.
yes, sir.
Based on what you were discussing earlier. So,
Mhm.
but if you buy, if you don't get your router from the ISP, you buy your own, then that's not going to be a public one anymore. It's going to be like Netgear and all the other good stuff.
What do you mean it's not going to be a public one?
So, I mean, like my modem is from my ISP, but my router is, I bought my own router. So
Yes, you can. Here is what you can do. You can, because the modem you are getting, your ISP doesn't sell their modem to you. They are renting their modem to you, and you're gonna be paying them. It's like $15 a month. It's part of your bill. So at home, I have my own modem and I have my own router. I have like 10 routers at home. You know, but if you have a router, you should be able to configure it. Routers don't just work automatic. It's not plug and play, right? You just buy and plug, then the router starts routing. You have to, it has to be configured somehow. And you have to know, because your ISP will send the router pre-configured that it can just plug and everything starts working. And they'll do the bare minimum in terms of security, you know, to secure your network from certain malicious stuff out there on the internet, you know, and block certain ports that are supposed to be blocked, you know, and all that. So if you are getting your own router, then you should be able to do all those stuff yourself. If you can do it, well, that's fine. I am not doubting your capabilities, but you can actually buy your own modem and buy your own router. However, if you have any internet issues, your ISP is not going to come help. Be aware of that, because you're not using their router, you're not using their modem, you're just using their internet connection. And they'll tell you the internet connection is stable. from our end, we see that you are getting connection. So if there is something happening within your LAN that has to do with connectivity, and you are not using their router, they will not troubleshoot any router that's not theirs. No way. So have that in mind. But you can absolutely buy your own router and your own modem. So you cut away all those fees. But you should have someone that can help. I'm not saying that you should call me when you have a problem.
I was about to say, help you out.
I will charge you if you call me. But you can absolutely do that. Yeah, it's absolutely fine for you to do that. What our advice is, you can get rid of the modem if you don't want it. If you are using the modem router combo, you can get rid of the modem. Go buy your own modem and put in between. Modems don't need a lot of configurations. You can plug, you can just buy and plug, you know. So you won't, modem, like I said, they'll just transmit and translate the analog to digital. That's what they're built for, you know. But all the configurations happen in the router. So if you don't want to be paying that $15 fee, that is part of your bill, you can go buy your own modem. I can make recommendations. They'll cost like $100 or so, but it's gonna save you money, right? Yeah, any other question?
Okay, I'll ask after class or on Wednesday.
Okay, so let's continue building this network. So Faith, you are the architect. Let's go back to you. So we have our modem. We have our modem. We have our backbone switch, our backbone router, our backbone switch, right? So what should we have right here, down here? What's the next device we can throw in here?
That's where you have your laptops, your desktops.
Okay, so we can have one office here that we have our laptops and our desktops and all that. And we can have another office here at this corner. No, let's say in here, within here. So let's say this is another office in this building right here. And then this is another office in that building. And let's say this is another office in that building. Okay. So what else do you think, Faith, that we should have in this first office right here, where we have our router, we have our modem, we have our switch, modem, router, switch. What else do you think should be in here?
Access points.
Yes, access points can be all over the building. So we can have one access point here, you're right. We have another one, we have another access point here. We have another access point here. So these are other machines in here, other laptops. Okay, so what else is missing in here?
Your cables.
Yes,
Like
the cables. When we
RJ45.
start connecting, making all these connections, these wired connections, it means we already have cables. But there is something that should be in here too. Who can help?
Wi-Fi.
Good attempt. Jarvis, what do you think is missing in here?
Another switch maybe.
Of course, there will be standby switches that are supporting the main backbone switch. So they're going to be the main router and they're going to be a standby router. They're going to be the main switch. They're going to be a standby switch, right? These are backbone switches, very, very expensive. But there is a device that should be in here that I want you guys to pick up.
Ebenezer says server and data center.
data center and server, or
Yeah, Ebenezer says server. I said data center.
okay. Ola, why do you say data center? And when you say data center, what do you mean?
I mean, all the stuff that's going through the network. If you need to pick something up or you want to find something about the company, that's where it's going to be stored and secured. I remember in our first class, you said that's the most difficult place to enter because that's where all the company secrets is hidden.
Okay, so do you think we can fit a data center in this building? Let's say we're on the fifth floor of some commercial building in town, downtown Dallas, and you know that in one of the videos I showed you the size of a data center that is like the size of a football field. How is it going to fit in this building?
2 points. I'll go with what Ebenezer said. Server.
Senior Gerald.
Yeah, that's one thing you guys got to understand, the difference between a data center and a server. A data center is made up of a bunch of servers. That's what a data center is. So if you say a server and they say data center, that means you're getting somebody confused.
Yes, that's what I was trying to clarify, just to make you think and know what you're talking about. So Ebenezer is right. Ebenezer said server. There will be servers in here. There will be servers in here. So you can have one server here. So this is where you're gonna have all the racks. All of these devices I'm showing you, they're not gonna be single devices. They're gonna be in racks, in server racks. The switch is gonna be in a server rack, and I showed you a picture of the rack, right? In a previous class. So you're gonna have all these servers in here that are gonna be on server racks. The switch is gonna be on a rack, you know. So you're gonna have all the servers in here. So this entire room, let me move this and let me move it a little bit. So this entire room, this part of the office, all the way, everything here, everything in this part of the office will be known as the server room. So the server room doesn't just have servers alone. The server room will have the switches. It's gonna have the backbone switch, the backbone router, the modem. All of them are gonna be in the server room. Do you guys understand that?
Quick question. Are we saying all data centers are very big? I assume that it was going to be different sizes based on the size of the company.
Okay. Ola, at work, they call it a server room, right? But when you're talking about a data center, you're talking about a huge, I showed you the size of a data center.
Oh, so a data center is a lot of servers, but
Yes.
server room is a smaller size, but data center
Exactly. You can call it an in-house data center, but you're actually talking about your server room. You're not talking about an actual data center. So the distinction here is for you not to confuse a data center and a server room. So think of a server room as a smaller size of a data center, because you're just gonna have like maybe 5 racks in here, 1, 2, 3, 4, 5, or 6, and they have the servers stacked on the racks and the switches and all that. You know, I showed you an example of a server room one time. Let's go to YouTube again so you guys don't confuse this concept. This right here is going to be a data center. These are data centers in here, right? Look at the size of this thing. You know, look at this one. These are data centers. You know, these are all data centers. So this is a server room. This is the server room rack. This guy is going to put all the servers are going to be racked on this thing. So let's go back here, and this is a server room right here. This is a typical example. A server room will look like this. See, a server room will look like this. Okay, now you see all these cables, they'll run from the server room through the walls to various parts of the building. So that's how a server room is going to be, right? So,
Senior Gerard, one
yes,
quick question, please.
yeah.
So as an admin, are you going to be required to do all those wiring, or is that something that the network engineer does?
Yes, that's something that the network engineer does. But you might have a situation where you have to go into the server room and maybe reboot a server, for example, or maybe change the power supply of a server. You know, you have to understand the server room. You don't have to go in there and like, okay, what is happening here? I've never seen anything like this before in my life, and be panicking, because it can be intimidated in there. You know, it can be. You know, so you have to go in there, understand. That's why I spoke to you guys about the network topology and knowing the network infrastructure, how everything is connected together. Because you might have a situation where they buy a new server and you're actually in charge of taking that server in the server room, racking it, putting it on one of those racks, right? And doing the wiring. So you have to know where the backbone switch is. Because if you rack and stack that server, there needs to be a connection between that server and the switch and the main switch, right? So you have to know where the backbone switch is, and then you're gonna know which ports are available on this switch for you to take that new server and connect it to, right? And then they're gonna be like, you saw all the wires here. So these are all the these are all the servers and the switches, everything. They're gonna run these wires through from the server room throughout the building. And where you are seated with your laptop, you're just gonna see a little port by the wall where you can just plug a cable and you start walking, right? Everything is what you should. All those little ports you see where you can just connect your laptop and you start walking will connect to one of these cables that are coming from the server room. And that's how you get internet at work.
Yeah,
If you're not using a wireless connection.
Yeah, one other question, please. So
Yes.
let's say in an interview, on an average, how many servers can you have in a server room, so that when they ask you that how many servers have you worked with, or are you currently managing on site, you
Yes.
don't go and
So
say a ridiculous number.
It depends. It depends on the size of the company, because remember, size of the company matters. If you say you are working for a startup and you are talking about 500 servers, that is laughable, right? So if it's a medium-sized company, then you give a number that makes sense. But again, you have to differentiate between the physical servers and the virtual servers, because you're going to have more virtual servers than the actual physical servers. So one of the physical servers itself can have about, say, 20 virtual servers on it. So now, which brings me back to your question, like, okay, when you say server experience, what are you actually talking about? Physical servers or virtual servers? Are you actually talking about touching the hardware or virtualization? You get it? So they will need to clarify that question to you, but in a situation like that, they'll most likely be referring to virtual servers. Yeah.
What would be a good number? Like, okay, so
It depends on the size of your company, bro. I cannot really. So you
So
need to
with
research
that question, if it depends, if you're working with a company which has more than 1,000 and plus employees, you can have more than a certain amount of servers. You don't have a fixed amount of servers in a server room. As bigger as the company goes, the more servers they need, because some servers, you have physical servers on hand, and then you have virtualized servers too as well. Servers can go from 1,000 and above, because the server, you can have servers that manages backups. You can have server that manages data. You can have server for networking. You can have servers for different things. So it has as much as more as possible. As Jeda said, it depends on how big the company is. It can go for plus and plus sizes of servers.
So let's say
that question does not have a specific answer. It has an indefinite answer. You could just tell them that You guys have more than 1,000 servers. You don't have to give them a specific, yeah.
Yeah, that's what I wanted to know, so that you don't go and just say, oh, I manage 2 servers, and
No.
they look at you like,
you have to say, hey, the amount of servers in any environment will change based on the workload, right? Today, you might spin up a new server. After tomorrow, you might be shutting down another server, right? So, but there's going to be like some servers that are permanently up and running. Then as you guys are doing different projects, you're going to keep adding to servers. So you're going to keep adding new servers. So there is no fixed amount. So you can give them an estimate that, hey, I manage between 200 and 500 servers, but it changes. You know, there is no fixed amount. So you just give them a range, you know, say between 300 and 500, or between 200 and 500, or between 500 and 800, you know, based on the size of the company. Yeah. So I think we are almost done with this line.
Thank you.
So before Charles takes over, so you're gonna have the switch here. All these servers here are gonna connect to the switch through wired connection. So all the servers here will connect to the switch. The access point here is also gonna connect to the switch, which is connected to the router. You can connect the access point directly to the router, or you can connect it to the switch that is connected to the router. So everything is connected to the switch. And then from the switch, through the walls, everything will be connected to all these machines. You have all these connections to all these machines. So these are all wired connections, guys. You know, so everything connects. And remember, your router will also have wireless capabilities. So people want to connect through Wi-Fi, they'll also get the Wi-Fi connection from the router, right? And then you have these access points. What is the use case of an access point, Jarvis?
Access point, like just as the name implies, so the connectivity, like what the network passes through.
That is not true. Who else can try? Emeka.
The purpose for access point is for security reasons.
Come again?
I say for security reasons.
That is not true. Cesar?
That's a point to check for connection if there's like a breakdown or something like that. You could go to troubleshoot. That means like a connection goes from there to the computer.
Not entirely true.
Extend the internet connection.
Thank you, Faith. So guys, your access point is used to extend the wireless connection. There might be some area in the building where the wireless connection is weak. How do you keep the wireless connection strong all over the building? You're gonna have access points. It's the same thing in your house. If you have a room in your house where your Wi-Fi connection is weak, right? What you need to be doing right now is to go to a hardware store and buy an access point. The access point is going to connect to your router, and it's going to help extend the range of your wireless connection. So if there is a building that is far away from the server room, you have an access point in that office. Sorry, if there's an office that is far from the server room, you have an access point that connects to some other access point that connects to the router or the switch. So the access point will extend the wireless capability, extend it. So if I have an access point in this office, the next office right here, I might have another access point. So the further the office goes, the more buildings the more offices you have in that building, you keep putting access points. Instead of putting routers in between, you use the access points to extend the wireless capability. Take note of that, guys. It's very important.
I have a question.
Yes.
What cable do you use to connect the access point and the router? Is it Ethernet cable?
Yes, it's always going to be an Ethernet cable. You will not find any cable in a network environment that you don't know. It will always, when you're connecting devices, the chances are you always use an RJ45 or a Cat5 or a Cat6 or a Cat7. Otherwise, known as Ethernet cables. Any other question? If not, I'll hand it over to Professor Charles. I hope you guys understood the local area network we just designed, because I'll ask again tomorrow, and I don't like the answers I got today. I thought we were just gonna go like very, very fast, you know. But try to go online and look at images of the way local area networks are designed. And within the network, okay, so one more question. So based on the way we designed this network, what kind of network, what type of network system do we build? Do we, Jarvis, do you think it's a peer-to-peer or a client server? What kind?
Client server.
Okay. Good job. Charles, it's all yours.
All right, guys, welcome back to today's session. Where did we stop yesterday? Can someone remind me?
I think we stopped at configuring static IP addresses.
I think we're talking about DNS related issues. All right, did you guys have any questions about that part? Did you have anything you needed me to clarify about when it comes to DNS, when it comes to configuring a static IP address, why we need to have a static IP address instead of a dynamic IP address? Did you guys have any questions? Because if you don't, I do have some questions. Is there anything that you guys needed me to clarify? All right, interview question. Where would you go? Let me choose someone. Let me open up the list of the names that I do have. All right, Bismarck, where would you go to configure a static IP address on your Windows server or on your Windows laptop? And how would you go about that? Interview question. What would you tell the interviewer? You guys can hear me, right?
Bismarck, the question is for you.
Yes.
Bismarck, that was your question? All right, I don't, you're taking a long time to respond. The interviewer won't be happy if you took that long to respond to a question. All right, does anyone in class want to give that a shot? For instance, an interviewer asks you, so I do have a dynamic IP address on my Windows server, and I do have some important resources that users access through that server, and I don't want that IP address to change. I need that IP address to carry based on what we discussed yesterday. So the interviewer goes ahead, or the manager goes ahead and asks you, how would I go about configuring a static IP address on my Windows server? Anyone wants to give it a shot?
Let me give it a shot.
Is that Jonathan?
I will go to the IPv4 settings, and on that settings there is the DHCP, which is automatic. And if you look down,
how would I access the IPv4 settings configurations for the server? How would I go? For instance, you've logged into the server, you're in the console. So how do you navigate to the IPv4 configurations of the server?
Network settings, that one.
How would I go to the network settings?
So you go to the control panel,
Your
you go to
control panel.
the task bar, then you type in control panel.
All right, just say, okay, you go to the control panel, and after that, you're able to access. All right.
Yeah, so after that, I'm able to access the IPv4 settings.
All
then
right.
on the settings, we have the DHCP, which is automatic. So I will click manual. Then from there, I use the command prompt to find the IP address for that particular laptop that I'm configuring. Then I will write the IP address. I'll note the IP address down. Then on the manual portion, I'll write the same IP address. I'll configure the same IP address. Then the subnet max will fall automatically. Then yeah, before that, when I go to the command prompt, I would type an IP config all, so that I will know the DNS IP address and also the default gate IP address. So I'll take all that down, and when I'm doing the static, I'll pretty much fill the information in, save, and go back and check if the change has been altered.
All right. Amazing. You went even into much more details than what is required in an interview. So that's amazing. All right. Another question. Have you guys, Jared, have you done a bit about ports? Have you guys done done anything about port numbers?
Not yet.
All right.
I just told them, I just gave them a high overview of protocols and their ports, but we still need to touch on that. I promise sending them by this weekend the protocols that they need to know, and the ports that they need to memorize. Otherwise, if you want to call it cram, you have to memorize certain ports. And yeah.
All right, guys. Bismarck, back to you. What is DNS and what is it used for? Or just tell me more about DNS and what you know about DNS. How would you answer such a question in an interview? Bismarck, are you there? Yes. Bismarck, are you there? All right, someone else. Jarvis, are you there?
Yeah, DNS is a computer server that contains a database of IP addresses and associated hosts. So
all right, first of all, first define what is DNS info. What is DNS? That was the first part of the question.
Domain name service.
Okay, it says service. All right. So okay, then domain name system or service. All right.
So it's a kind of computer server that contains a database of IP addresses.
Is it a server?
Yeah, it's a computer server.
You say domain name service or system?
System, domain name system.
Okay, it's a system. All right. So what does someone can you, all right, just a bit, can you guys mute yourselves if you're not responding to questions?
Okay.
All right.
So it's DNS is domain name system. It's a server that contains a database of IP addresses and the corresponding host names of those IP addresses.
Are you sure it's a server or is it a service?
A server.
Domain name system. All right, I'm talking about the domain name system, not the domain DNS server. So there's a difference between the DNS server and DNS, the concept. So we're talking about DNS as a concept.
Yeah. I think, Jarvis, I've gone through this like 5 times in class, trying to differentiate between the protocol and the server. And I said a lot of people mix the two concepts together. You know, and I've hammered on that same thing, right, Jonathan? Even Jonathan was, even
Yes, sir.
yesterday, I still touched on it. I'm like, don't make this mistake. A lot of people make the same mistake, you know, so you shouldn't be making that mistake. You should be able to differentiate between the protocol and the server itself. You know, so don't confuse both of them, right? A server does one thing, a protocol does something else, you know. So
All right, guys.
Let me just answer the question to them for them,
Yep.
Charles. So actually, DNS is a dynamic whole domain naming services. What it does is that it converts it's a protocol. Oh Lord. So it's a protocol. It's a protocol that converts convert IP addresses into host name and also host names into IP addresses. For instance, for example, when you go to command line and you do IP, I mean, you want to ping, you ping google.com. You see how when you go in there, you write google.com instead of writing the IP address of Google. When you do ping google.com, it converts that name into an IP address. And it goes the same way. If you, let's say you put in ping 10.00, 10.0.0.1, it converts that IP address into a host name. So that's the use of a DNS.
All right, guys, you got that? I want you guys to respond a bit faster. For instance, when I call out your name, and if you cannot answer the question, just say pass. And then I'll give another person a chance to answer the question so that we can be able to redeem time. And also, these sessions we have where we ask you some questions before you go into a class are very important because they give you a tease of what lies ahead in regard to the interviews. And also those small misconceptions you may have, not misconceptions, but concepts that you don't have grounded down, things like a DNS server and the DNS protocol. You guys need to know those things, DHCP protocol and the DHCP server. You need to know those tiny little differences because they can throw you off. So remember, I told you guys, be good at the basics. You don't want to be in an interview and an interviewer asks you a question, you're like, you're like, all right, it happens. It happens. And sometimes that's how you get to learn. But make sure you have those concepts down. So today we're going to talk about some network categories and components. So usually when networks are laid out, there's the physical layout of a network and there's a logical layout of a network. So guys, remember yesterday we did things like a trace route. We did a trace route to google.com. We did a trace route, not trace route. Trace route is for Linux. We didn't do Linux, we did Windows. We did a trace route from our laptops. If you guys did it with me as we're going along, we did a trace route from our laptop and we determined the hops or the steps in which that data or the packets were being sent from our laptop. Guys, mute yourself if you're not speaking. So we determined the steps which, guys, can you mute? Everyone, can you mute? Oh, Gerard, can you mute everyone? So we determined the hops that our data or the packets were taking from our routers on our internal networks to Facebook, to which, because we're trying to connect connectivity and the hops, you see the hops that our data was taking. So today we're going to look at the physical topologies, and we're going to look at the logical topologies and what the difference between the physical topology and the logical topology is. So for instance, when you are told to document or to draw a diagram of your network and they tell you, can you draw a network representation of how our data moves from our internal network to the Facebook servers? Now, you're not going to go ahead and draw all the small lines of, for instance, a line connecting from here to your ISP provider, another line from your ISP provider to another maybe ISP provider in Connecticut, and then maybe to another server between Connecticut and New York, and after New York, and after Facebook. The diagrammatic representation of that is just going to be one line. So, Jared, do we have that drawing tool? Jared?
Say that again.
Yeah, if you go to Slack, you can see the whiteboard.
I needed to use the whiteboard.
Yeah, it's in Slack. If you go to Slack, the link is
Go to
there.
Slack and then go to whiteboard.
All right, hope I do have Slack on this computer. Let's see if I do have that. The Slack I do have here is for my other job, so let me see if I can get a drawing tool. All right. This looks sketchy, but let me see if it will allow me to draw. Good. Okay, guys, amazing. Is the internet amazing nowadays? All right. So this is me right here. And I'm in my office environment. And so my manager comes to me and tells me, Charles, I need to see a diagram that represents the logical representation of our network and how we and which other servers we are connected to. So,
Chad, are you sharing your screen?
Oh, guys, are you seeing my screen?
No, we see you. We don't see your screen, so you probably have to share your screen.
Okay, let me. So all along, you guys have not been seeing me, right? I've not been seeing the screen.
Yes.
We've been seeing you, but we're not seeing your screen that you're sharing.
All right, Gay. Sorry, yeah. Can you give me permission, Mr. Gerard? Thanks for that. I thought you guys were seeing what I was doing. Jared, I'm still. Oh,
yeah.
right.
What do you need, Charles?
Actually, I was explaining some concept without sharing my screen.
Okay. Sorry.
Can you give me the ability to share?
Yes. Yeah, go ahead.
Okay. All right. Are you guys seeing my screen right now?
Yep.
All right, cool, amazing. So sorry about that. I thought you guys were seeing my screen and I just started talking. So Kingsley, thanks a lot for for reminding me. All right, I was talking about a physical topology or a layout and a logical one. So Jared, are you recording?
Yeah, I've been recording ever since.
Okay, cool. So what I was saying is your manager can come to you and tell you, Jarvis or Faith or Jonathan or Bismarck, I need you to show me the servers, the way we connect to our servers in New York, or to the way we connect to our servers that are around the East Coast. So when he does that, like I explained yesterday, we did a hop. So the hop represents the different routers that our packets are sent through in order to reach the final destination. So that is a physical representation or the physical layout of our network. So the hop will start from where I am right now in the office building on the router, and it will go through all those physical routers till it gets to our final destination. But when I'm drawing the diagram of that representation, I will not include all those hops that the packets take to reach our final destination. What I'll do, so what I was saying that was amazing is I was able to go to the internet and just pull this out. And let me see. So we can have right here, and we call this server 1. Are you guys seeing my screen?
Yes.
All right, cool. So this server right here, and we may have another server. or another data center, or a server in another data center called S2. So for instance, now you do have a server in this data center, which is down here in Boston. And then you have another server in a data center that is, let's say maybe it's in Virginia. So when I am doing a logical representation of these servers, I'll just say I do have a server here in Boston. And this server in Boston backs up to this server right here that is in Virginia. So this is when I'm doing a logical representation, I won't say this, when this server is sharing information with this server, those packets are going to go through New York. And after that, maybe before New York, there's Connecticut. And before Connecticut, there's my ISP provider. So that is the physical layout of your network, of how the servers go from S1 to S2, from server 1 to server 2. So, but the logical one, the logical representation, you just have to do that. I'm drawing server 1 connecting to server 2. So that's a logical representation. So if you have another data center in Europe, you just have to do S3, and you do have this S3 in this data center right here in Europe. So a logical representation just shows you an overview. It's not a detailed representation. It shows you an overview of how your network is connected. But for the physical one, that is the actual cabling. Like you have maybe Verizon cables getting into your office. And then those cables will go to the data center. And after that, they will go to S2, which is in Virginia. And after that, there's maybe physical cabling to your data centers, which are in Europe or which are in another different region altogether. Do you guys know understand the difference between the physical and the logical representation of network diagrams of a network?
Yes.
That was Jonathan. Anyone else? Do you guys understand
Can
my
you please
explanation?
explain the logical aspect again?
All right. So is that Faith?
Yes.
So do you understand the physical representation?
Yes.
What is the physical representation?
The physical representation is that, okay, I think it's a logical representation, I understand. But what I understand right now is that it goes from S1 to X2, but the S2 is your data center. But then the one from the S1, first of all, goes to Connecticut, through New York and all of that before it gets to the data center. So I think that's the, so with a logical one,
so
you
that,
don't have to, so with a logical one, you don't have to explain to say it goes from Connecticut to New York. You just say it goes from maybe Boston to your data center.
So yeah, it's most of the endpoints. So I do have my starting point as here in Boston, and I do have my final destination as Virginia. So those are the two data centers. I'm not going to include the details in here of how the cable
That's for logical, right?
Yes, this is for logical. I don't have to put in the details of how the cabling is done.
But with the physical one, you have to put in how it travels.
Yes. So yes, amazing. Yes, that's true. So this is a big. I gave you this example, but you could also work it. It could also be within your office, within the internal office. You could have your laptops in your office, but guess what? This laptop right here is connecting to another server in your office, right? And it's accessing resources on that server. So I do have my laptop right here, and that laptop is accessing resources on this server. So which representation is here right here that I've just drawn out? Is this a physical representation or is it a logical representation?
Is it logical?
Yes, guys, this is a logical representation. If it was a physical representation, guess what? I do have a switch, right? And I do have a router. And guess what? I could have a firewall. So before my packets go to this server right here, they could go through a switch. And before they hit this server right here, they could go through a firewall. And from the firewall, they could go here, or they could go through the router, and the router sends it to the firewall. So this is the physical representation whereby I actually draw out, or I actually use the physical, include all the physical cabling. So and we can even go a bit more detail and say, okay, the laptop is connecting to the switch using an RJ45. So I'm including as much details about my physical implementation. And this switch, I could say, is connected on port number 20. The laptop is connected on port number 20 on this switch. And after that, this switch is connected to the firewall on port number, maybe I could say 2. So guys, the physical implementation shows you the physical path of the data, the physical, how the data is going from one point, which is a laptop, to its final destination, which is my server 1, where I want to access my resources. But the logical one is just server 1 and server 2, and that's it. Guys, is that clear enough?
Yes, for
All
me.
right. Anyone else still has issues with this concept? Anyone has any issues with this concept? I would take that for a no.
So what you're saying, it's about like the physical, it's kind of like when you talk about physical, you're talking about more data, like you have to explain all the steps, right? Is that what you're trying?
As it says physical, that means it's the actual cabling.
Oh, okay.
The actual cabling. So the logic is just like a line. Okay, I have laptop 1 connecting to laptop to server 1. So it's just like giving someone an overview. So that's a logical representation. So I do have my laptop here connecting to my server and accessing resources. But the physical implementation, or the actual physical topology, is the actual movement. Like, okay, I have my laptop here. I'm plugged into, I'm plugging an Ethernet cable, RJ45, into my laptop. And that Ethernet cable will go to my switch. And after that, it will leave my switch and is connected to a firewall using another RJ45. And after that, the firewall, from the firewall, there's another onto the server. So that's the actual physical topology. Does it make sense? Yes?
Yes.
All right. So physical components. So they're used to create a physical topology. So guess we have just been looking at these physical components. So we looked at things like the Ethernet, the optical cables, the fiber cables. I know air is sometimes the air can also be used to connect devices. That's like Wi-Fi. Guys, quick question. If I have an Ethernet cable connected to my laptop, and also if I'm using Wi-Fi, which one is faster? Is it the Ethernet cable or is it the Wi-Fi? Interview question. You just got that interview question 1 month after finishing the course. I'm just trying to test and see if you're really into IT, as you're telling me that you're into IT.
I think cable.
Is the internet cable.
Internet.
Are you guys sure?
Yes, positive.
Yes.
Why? Why is the physical cable, why is the Ethernet cable faster than Wi-Fi?
You connected
Can I try, sir?
directly to the source.
Who said he wants to try? I had a voice.
Yeah, actually,
Can you
the
say your name?
concept,
Can you say your name before?
Bismarck, Andrew Azar Bismarck, sir.
Yeah, Bismarck, yes.
Yeah, I'm able to connect to you. Sorry, there was a mix-up along the way, but I resolved the issue.
I trust you.
Okay, thank you so much. Actually, the answer to that question is a little bit above the scope. We don't even need to know why, but we just know that it's like that. Reason being that It has to do with optical fiber technology. And
Amazing.
optical fiber technology in the Ethernet cable has a concept of what we call a refractive index. And there is inbuilt concept of refractive index where we know the speed of light, the waves in the optical fiber travel at the speed of light, whereby the optical fiber is built in such that we have some specification called either a step in index or a graded index fiber. It is a little above us, but let's just accept what we have right now. Thank you.
All right, Bismarck, another question. What is the speed of light? Since
The speed of light, actually, if we put it in meter per second, it will be 3.0 times 10 to the 8. But in centimeter per second, it will be 3.0 times 10 to the 10 meter per second.
All right, let's stick to the meters.
Okay, so okay. Just to clarify something, Mr. Bismarck. So Professor Charles did say, okay, what makes Ethernet cable connection faster than Wi-Fi connection, which is more faster, and the class said wired connections are faster than wireless connection.
Yeah.
But here is where you went off. The thing is, he didn't say wired connection by fiber.
Okay,
right?
okay.
He wasn't talking about fiber. It
Okay.
could be a normal Ethernet connection, not using fiber.
Okay.
Right? So I think that's where there is a deviation from what he was asking. Because if you go back to one of the documents that I sent to you, you'll be able to answer. Someone did say, okay, he thinks the wired connection is going to be faster because you are connecting directly to the source. I mean, sorry, I'm laughing. I don't mean to be sarcastic or anything, but yeah, in a generic sense, that answer could be right. But we are IT professionals right now. We cannot give we cannot have any vagueness into our answers, right?
Yes.
So, let me make reference to one of the documents that I shared with you last week. I think I sent it to every one of you individually. If you read through that document, I gave you the speeds of transmission of every, I started with Ethernet. What's the speed of transmission of Ethernet? What's the mode of transmission? What is the range? And I went to fiber and I went to wireless. So looking at that document, you should be able to answer this question. You should know why a wired connection is faster and which wired connection is faster and why, going by the mode and by the medium and by the speed. So make reference to that document and challenge Professor Charles, please. Don't disgrace me.
Quick question. There is an RJ45 cable for gig speed, I think, correct? Or am I wrong?
For what?
For gigabyte speed, like if internet connection for gigabyte speed, this 400 megabytes.
I think that should be in the document that
I gave you in the document. I gave you CAT cables and the different speeds of transmission, all those things. So go make reference to that document. You answer that question easily. So Ola, I think I sent it to you too, and you responded with a big thank you. So
he wants to be like me. You store all this information, but you never use it. All right, guys. Bismarck, thanks a lot for your response, and thanks a lot for reminding me of physics. Okay, guys. We just talked about physical components, which Gerard just clarified. He gave you some notes, so please refer back to those cables. Because recently I went to the, I said I took some servers, I drove down to Virginia, fourth quarter 2020, and I don't have any quote unquote network background, like I was a network engineer, but I was required to rack those servers, purchase the servers, install the OS on those servers, configure software on those servers, configure things like SSH, which you guys were going to learn later, like remote connectivity to the servers. I had to go and choose and buy the correct cables, Ethernet cables for those servers. So when Gerard sends you out these documents with all these RJ45s and a Cat5e, and he tells you this is the transmission speed, and he says a Cat6 is this transmission speed, all those are important. So imagine I went ahead and set up those servers that I bought, maybe a Cat5, and yet my network needed maybe like a 10 GB speed for our clients to connect, because we're in the financial services and our clients need to connect to our resources to make purchases. And that should be a fast connection for them to access their resources. So don't take that for granted, because you don't know the role that you're going to get and all this knowledge that you're going to be acquiring. You're going to be in an environment where you're going to be working with network admins. And so when you hear them chit-chatting about, oh yeah, I just bought some Cat 6E cables, you shouldn't be like you're an alien on some other planet and you don't understand what they're trying to talk about. So learn this concept, memorize. At first, you may have to memorize those cables and all the stuff, but later on, it will become second nature, and as you get more use and exposure. All right. So logical topology. So guys, we already discussed this. Discusses how data is transported across cables or in the air. This is data, how data is actually transported. So that's a logical connection. So it uses protocols just like IP, and this is used for communication. So I already explained this about the physical cabling. I won't go through that. And then endpoints, we already discussed those already. I discussed about the physical, I explained this already about the physical components and the physical connections, switches and routers. So this is just, we're still in the definition bit of it and just going through the low level, just the overview. And then later on, we're just going to go through the details. So switches and routers, so these are endpoints that are used to connect to, so devices that endpoints connect to, and they provide intelligent switching of data in a local area network. So we have devices that connect to switches, and we have devices that connect to routers. And based on that, the switches and routers determine what the best path for our information to be shared on the network. So they basically route traffic from one network to another, or from one device to another. So that is just an overview about switches and routers. So later on, we're just going to go into the details about that. So another thing that we're going to talk about is characteristics of a network. So why do you need to know the characteristics of a network? So you need to know this in order to understand how a network operates. And these characteristics of a network describe things like network performance, and they help you understand and structure the structure and design consideration of a network improvement. I already talked about that. Just a moment, let me find myself. All right, speed and bandwidth. So right now I'm talking about one of the characteristics of a network. So speed and bandwidth. So that's a measure of the data rate of a given link in a network. And this is measured in bits per second. And then another characteristic of a network is three of them are cost, security, and availability. So cost is the expense for purchasing network components. Also installing and maintaining a network is also part of the cost. So sometimes the cost of installation is higher than the cost of the equipment. This is something that's common nowadays. You may buy a network equipment and it costs maybe $100. But the cost of installation, when you call someone to install it, they may tell you, guess what? To install this device for you will cost $1,000. So those are things that you have to put into consideration. For instance, if you're hiring a place or a small company, whereby you are acting as a system admin and a part-time network admin. So these are things that you have to put into consideration. And then security is another aspect, characteristic of a network, how well a network is protected from both inside and outside threats. For instance, attacks from hackers on the internet. So that's another aspect of the network that you need to understand. And then the other aspect is availability. What's availability? It's the measure of the probability that a network will be available for use when needed. So some of you are on Comcast or some of you are on Verizon. And there's an SLA, which is called a service level agreement, where Verizon or Comcast it tells us that you should be expecting to have network 24/7. But the question is, do you always have network your network connectivity at 24/7, availability at 24/7? So when you are working IT, availability is the other thing that you have to put into consideration. And how is availability represented? I do this on a monthly basis where I do send out SLAs. That's why I did include it here, whereby we have to provide documentation to show that our clients access the resources that they need and how much downtime they experience. So this is represented as a percentage of the time that a network will be available. So we know we do have, I drew this out as a quick reference. So uptime. So that's the time that a network will be available. So we know we have 24 hours per day. We know we have 7 days per week. We know we have 365 days per year. So how do we find our uptime? So the number of minutes in a year minus the downtime divided by the total number of minutes in a given year will give us a percentage uptime. So for instance, if my network wasn't down at all during the entire year, that means I'm going to have 100% availability. But if my network was available for 15 minutes, that means I'm going to get the number of minutes in the year minus 15 divided by the total number of minutes in each year. And then I multiply that by 100. And that should be able to give me my uptime availability for the year. This is not as important because you guys are not going to be on the networking aspect of things, but I'm giving you just a concept that you guys need to know because you may hint at it or touch on it at some point in your careers. And then scalability. You need to design your network in such a way that it's scalable. For instance, in a data center, when I purchased switches for the data center, I didn't purchase a switch with 3 ports. I purchased a switch with 24 ports. Just imagine you go ahead and purchase a switch with 4 ports, and after that you need to add more servers. What happens? That means there's literally, unless you're going to connect a switch to another switch, which will increase a bit of latency, but that means you have to have some downtime. That means your customers are going to be complaining, or you may have to go back again and do an entire purchase and purchase another switch. So this indicates how easily the network can grow to accommodate more users and transmission requirements. So you have to put all those factors into consideration. So you do not optimize a network for today's needs. Have growth in mind. I just gave you an example of what I did. I didn't get a 4-port switch because I had growth in mind. I was like, okay, in case the company grows, instead of, even though I'm racking up 2 servers, I bought a 24 gigabyte port switch because in the future, in case there's growth, that is taken care of. And I didn't purchase a switch that's 100 MBs. So for the switches, just a brief, I'm retracting a bit here. The ports in the switches support certain speeds. So they can go from a couple like 256 MBs all the way to like 10 GBs. So based on your network requirements, you need to make purchases with growth in mind. Like, all right, maybe in the future, we shall have to increase our transmission speeds from maybe 1 GB to 10 GBs. So don't buy a 1 GB switch. Buy switches that support a 10 GB link speed. So I think that is what we're going to talk about here. And then the other thing is reliability. the dependability of the components. Have you guys noticed something that nowadays devices fail a lot compared to maybe devices that were manufactured in 1995 or 1980s? I know some of you may be babies, but the thing is, some products, we know that some products last longer than other products. For instance, sometimes I just bought headphones. I bought some headphones from, I bought headsets from Philip, but within 6 months, they're already giving me issues. So I went ahead and said, okay, let me sacrifice $200 and buy something from Sony and see how long it's going to last. So right now I'm giving Sony a chance and see how dependable is Sony. So when you're purchasing devices, do your research and find out how dependable is maybe a Dell server compared to an HP server. Because at some point, we know all devices get to fail, but how soon is that going to happen? So you need to know things like mean time before failure, how long a device is going to be in use before it fails. For instance, we have had in our data center, we had some servers, when I did the infrastructure upgrade, we had servers that were there for about 7 years. These servers had been running for 7 years in a row without any of them being powered down. Now, just imagine maybe we had just bought maybe a crappy kind of like server, or a server that's not maybe one of the brand names, not only brand names, but which is dependable. It would have failed maybe within 2 years. So you need to buy equipment that's reliable. It may cost a bit more, but you know it's going to serve you for a longer time. All right, so right now we're going to look at network topologies. I'm going to run through this because I want to go through, after midday, I want us to go through another important and interesting topic. So
Charles, can we take a break at noon?
Yes, that's my plan.
Okay, thank you.
Yes, that's my plan. That's why I want to go through this very fast.
All right.
3 minutes. I'll time myself. All right. Maybe we shall start from topologies when we come back. All right, guys, I won't rush through this. I have just 4 slides. Do you guys have any questions in regard to what I've talked about before? Let's use that for the 3 minutes. About scalability of the network, reliability of the network. Any questions?
Yeah, I just want to ask you in relation to these terms, the scalability, reliability. Are there any benchmarks, like benchmark which you can follow, which will tell you whether what you're selecting is good? For example, you just mentioned that you're getting headphones from Sony and you want to see if it's going to be good. Are there any benchmarks which can help you make good decisions?
Yes, all right. So for the headphones, that's different because sometimes I like using reviews. If someone gives me a review and tells me they've had their headphones for the last 2 years and they've not had issues, that would be a good review. But when it comes to servers and availability of resources, for instance, and reliability, you could also use things like specs, the specs of a server. If, for instance, I buy a laptop that has memory of maybe, okay, I do have a 16 GB laptop with a 500 SSD. I know a standard an SSD drive, solid state drive, and 16 GBs. As soon as I tap the power button, within less than 10 seconds, my display, my login screen is already up. But if I had a 4 GB laptop with an HD hard drive, that would take longer, almost a minute for it to power up. So that is one of the things that you can look at for how dependable and how reliable your systems are. So the specs are one of the things that you can look at when you're determining that in regard to availability of your resources. So you can use that as one of the factors when you are determining how reliable and how dependable your systems are. Now, for instance, some of you guys have so for a home network, in most cases, you just need the basic plan when you're getting internet. But when, for instance, you start your IT gigs and you have to two jobs. You may have to call up your ISP provider and say, hey, I need to be bumped up from, maybe you have 250 MBs to like 500 MBs because of the kind of work you're doing. Maybe you do maybe a bit of database related work, or you have many users in your environment. So based on all those, you can make a judgment on which aspect of your infrastructure or of your network that needs to be improved.
Thank you.
Question: how do you calculate your downtime?
Downtime. Yeah. That is, downtime is from the time that your systems go down to the time that they back up. So
how do you know in a year, the space of a year? Is there a way in the system, your machine, where it calculates your downtime for you?
It depends which part of the system. For instance, if a server, for instance, dies or goes down, that usually you can use, I think Jared will talk about the Nagios notifications. So you can have server or system monitoring tools like Nagios. So a system monitoring tool like Nagios, when a server goes down, you get a notification that a server has gone down at this time. And then based on that, you know the time that a server went down and to the time that you're able to bring that server back online. So from this time it goes down and you receive a notification from Nagios, the system monitoring tool, to the time it comes back up, that will be your downtime in that specific example of the Nagios. But for it's already 12, let me answer your question first. But for the case of what we do as in the payments, so from the time that that payment request hits the Apache server to the time that the Apache server responds back to the user, that can also be used to determine SLAs, not downtime as such, but service level agreement. So, but that uses a script to determine that, which is a bit different from the Nagios example that I gave you. So in this case, the Nagios example is the best example to explain downtime. Does that make sense? Does it answer your question?
Yeah, thank you. Yeah.
All right, guys, our break is starting and we have Jared 10 minutes, right? Jared, I can't hear you. I think you are muted.
Maybe 12 today, since the class has been long.
12 minutes?
Yeah, let's do like 12 because we've gone for like 2 hours straight.
All right, sounds good. All right, guys, starting.
So are you recording?
I think Jared is recording, right, Jared?
I want to say something that doesn't relate, please. Can you help me? Let me, so not to
Jared,
record.
Can you pause the recording?
Yeah.
Guys, so hope you guys are all back. So
is everyone back? Faith, why everyone got their cameras off today? What is going on? Why are you guys hiding? Faith, Jarvis,
Allah is back.
Emeka, Ebenezer, what's going on with you guys? Why are you guys hiding?
Back. We're waiting for Bismarck to finish.
Guys, switch on your videos, please. We said that's one thing we agreed on in the beginning of the class. We will not be hiding ourselves. We want to be fair to each other. So when you come to class, turn on your video, please. Unless your camera is broken like Ola, and we're still waiting for him to get a new laptop.
Ola's camera is not broken because we've seen him once.
We've seen him once.
So he just likes to stay off.
So we don't want.
Actually, I was on my tablet that day. That once on my laptop, my camera.
My camera just broke.
Okay.
Ebenezer,
I think my camera
what's
just went
happening
off.
to you? Please turn on your camera. We are not hiding here. Imagine I come to class one day and my camera is off. Charles's camera is off. Kingsley's camera is off. How's the class gonna be? You guys are not gonna feel that connection. So we are doing this for a reason, and we're establishing. When I look at you in class and I ask you a direct question, that's how it's gonna be in an interview, right? You're not gonna hide from an interviewer. There's no way you're gonna hide. So we are doing this thing. We are building all the skills necessary for you to get that job. So you don't want to start hiding from me or me hiding from you, because in a virtual interview, you will turn on your camera whether you like it or not. So we should be doing that. It's part of practice and an essential part of this class. So please turn on your camera. Let's proceed with the class. And it also helps with the way we interact with each other. I can look at your expressions and tell if you are getting the concept or not, and I can help you. Let's not hide from each other, please.
All right, guys, let me just rush through this. All right, topologies on how network devices can be connected in a network. So if you guys went through the network course or some of those topics, you should have seen this. The first one is a bus topology. Our computers are cabled together in a line using coaxial cables. So we do have this cable right here, the coaxial cable, and all these computers are connected to this cable.
Oh, we don't see your screen. Are you sharing it?
Stop. Yeah, it shares. I'm sharing.
Yeah, we can see it. We can see it. I can see it. You just need to flip your screen.
Yeah, I can see it too.
Are you all set now?
Not at my end.
Gerald, can you see my screen?
Uh-huh.
All right. So that means we do have the video. So
yeah, Caesar, it should be a personal problem from your end.
Okay.
All right, guys, we're running.
Everyone else can see the share. So if
change,
else
maybe
change
change one of the views. Maybe you're using a different view to.
Oh.
So try to do that and see if you can click around.
Good now.
Yeah,
All
good
right.
now. All right, let's proceed.
All right, guys. Bus topology. This should be obvious. All computers are connected to this coaxial cable for resources. The ring topology. So devices connected together. The last device is connected to the first, so it's kind of like all goes in a circle. And here you can be able to tell the advantages and disadvantages of all these. And then we have the star. The star, we have a switch in the middle, and all these devices are connecting to that switch. So this is the most common physical implementation, the star topology, where all these devices in the network are connected to the central switch. Compared it to the ring, if for instance, this connection here is severed, this switch is still able to connect all these devices. Only one device is affected. And then we do have the mesh topology. Every device is connected to multiple other devices. This increases reliability. That means if one connection goes down, at least somewhere, if for instance, a connection from this computer right here to this computer goes down, there is this connection from this computer to this computer to this computer right here. So this provides for self-healing because of the redundant links. Redundancy, that's another term you guys should read about redundancy. Just make a note about that, redundancy in networking. I'm not going to talk about it, so you guys make a note of that and read about redundancy. Don't go into researching an entire textbook or reading like 10 pages or coming up and making your own redundancy kind of like just a little bit. Ease yourself with redundancy and how redundancy works in a computer system. So guys, that's it in regard to the first part. So we are moving on to the next part. So for the next bit of this, we're going to be looking at the OSI model, and I'm going to give you guys an introduction to the OSI model. Can you guys see my screen? Yes.
Yeah, we can see it. Yeah, we can see it.
All right, good. All right, hope you guys love my art. Is there a way I can zoom this out? Guys, just a moment.
You should be able to do like a play. If you do play on PowerPoint, it should go full screen.
Where is that play on PowerPoint? Are you seeing it somewhere? Kingsley?
You see where it says preview on your the taskbar up top? Preview.
Preview.
All the way, yeah, to go, yeah, right there. Yes. But you could just double click on one of the PowerPoints, double click on one of them. No, on the,
I think go to slideshow. Go to slideshow.
Slideshow, yes. Slideshow right there on the task. Up top.
Where?
It's the animation.
Slideshow where you were before.
Slideshow. It's next to
where you hit
animation.
preview. You see where you hit preview next to preview.
Oh, slideshow.
Slideshow,
okay.
Yeah.
Okay.
Okay, now go from the beginning. You can play from the beginning or from current slide. If you look at your to the right,
from beginning, go from
right,
current slide,
from beginning. Okay.
Right there.
Thanks a lot. Let me see. All right, this is kind of like playing it.
You can always just hit the screen and go next, or you can just click on the arrow on the bottom. You see on the bottom where it says slide 2 or slide 1. No, all the way down, All
right, so I'm here.
No, I mean underneath the big slide where it says
the arrow says slide 2 or 15. Then you go to that arrow. That means you go to the next slide.
All right, guys.
Go to the bottom.
Okay,
go
bottom
to the bottom.
Is right here. Yeah.
No, down more.
Next to it. Yeah, slide 2 of 15. You see slide 2 of 15. That arrow tells you to go to the next slide.
Slide 2 of I'm getting blind. Slide 2.
It's right on the bottom of where you were at.
Yes, right there. You see where your cursor is? Go to that arrow that says the next arrow on the side where it says next to level 15.
All right, guys.
You see where your mouse is?
Yeah, right here. Maybe I'm not seeing it from my side.
What do you see there? Where your mouse is standing? What do you see on that part?
Maybe there's something that I'm not seeing that you guys are saying.
No, go back to that preview again. Go back to the preview.
All right, guys, I'm right here. I cannot see anything that tells me to go back, actually. There's
right here, where your mouse is.
My mouse says mute.
All right, you can use the arrow.
I think the arrow keys screen is not. It's blocked underneath.
Use the arrow keys. Use the arrow keys on your keyboard. That works.
All right, cool.
Left and right arrow keys.
Yep, I think that will do.
Yeah, that will do it.
All right, guys. All right, guys. The OSI model. So before we start, this is a question that you are going to be asked throughout your network, your IT career. It's going to be something you're going to be asked on an entry-level interview. It's going to be something you're going to be asked when you want to become a network admin or a systems admin. It's going to be a question you're going to be asked when you want to be a Linux admin, a Linux engineer, a site reliability engineer. This question goes from a newbie person into IT to the most advanced. You ask about the OSI model. They want to know if you do have, first of all, the general knowledge on how to go about when you are troubleshooting systems. So how did this, what is the OSI model? So the OSI model, from the definition, the internet definition, is a conceptual framework used to describe the functions of a network system. And it's the open systems interconnection model. So it's just used to describe the functions of a networking system. So to understand the OSI model, we need to compare how it was in the past to how it is in the present. So guys, remember, in the past, each manufacturer or each vendor used to manufacture their own devices based on their own model, because those devices were proprietary to those and controlled by those vendors. So for instance, you used to have a laptop. Let me say maybe the laptop was manufactured by maybe Dell. in 1980. And then if you wanted to use a mouse, you had to get a mouse that is manufactured by Dell. If I got a mouse that was manufactured by HP or another vendor, that mouse would not work. You guys remember those days? Or anything, or a scenario close to that?
Like Apple.
Yes. Yeah, now Apple is another example nowadays. You find like Apple devices just work for only Apple, which is an exception to the rule. But nowadays you find that most devices work together. For instance, I do have a Lenovo laptop. I do have a Logitech keyboard, and a Logitech mouse. But I would have, if I wanted, I would have maybe a Lenovo laptop. I would have maybe a Windows keyboard, and the mouse would be maybe a Dell mouse. And all these three devices would be able to work together. Why? Do you guys know why? Because there's a standard. There's a standard on how that was set for all these devices to communicate with each other using the same protocol, using the same language. So at some point, all vendors agreed. And based on this, they agree that, okay, we need to make our device interoperable, whereby they're able to communicate with each other, even though they are manufactured by different vendors. So that's the effort and the drive of how this standardization of the OSI model came up, so that we can enhance different devices manufactured by different vendors to be able to communicate with each other. So that's why this need for a standard-based model called the OSI came about. And guys, this was developed by the International Organization for Standardization, which is the ISO. You guys will get more into this, the ISO, because they do have other protocols and other security-related measures and standards that they've come up with. All right, so why the OSI model? Guys, it's a universal set of rules and requirements that are used to support interoperability between different products and software. So the OSI model provides, okay, before I continue, any questions right now? I would assume the silence means no questions. All right, the OSI model provides a layered approach to development. You guys understand what I mean by a layered approach to development, which allows for multi-vendor.
Charles.
Yes.
Yeah, sorry to bother you. So the OSI model, is it a model that was developed for communication among, let's say, hard drives or software? Like I'm getting a little bit confused. Or is it a model that was developed for communication over a network? Could you please clarify that for me?
So so the OSI model touches from the physical aspect, the network aspect, how transportation of packages or data between the network happens, to the application. So it doesn't touch only the hardware that I was explaining about. For instance, I may have a Windows document. Can a Windows document open up in a Mac?
Yes.
Yes, but am I using Windows to open it up in a Mac? Am I using a?
No, you are using a Mac operating system to open it up.
Exactly, but why is it like that?
You use some features.
Sorry, can you say that?
I said you would use some features. It won't be the same compatibility, but you use some features that words have that you cannot use with Mac.
Sorry, you're so faint. I'm not understanding your point. Jonathan, did you understand what he was trying to say? Someone understands what he's trying to say?
I think he mentioned that it will use some features.
You will lose features that the
Oh,
Mac.
you lose features. Okay.
That the Mac, that Windows, that Words has that Mac does not have. You know, like for example, you might lose the text formatting features and stuff like that.
yeah, you may lose the text formatting feature. All right, cool. But yeah, sure. But so my point is, I was answering Jonathan's question whereby, so the OSI model and all these touches from the physical all the way to the application layer, as we're going to see. So we shall see that layered approach to development and allowing for multi-vendor interoperability, and then it also allows for rapid development. Because guess what? The OSI model is broken up into layers. The physical layer is different from the network layer, which is different from the application layer. So when someone's, for instance, when someone is doing development, they can concentrate on just that layer in which they have a specialty in. So this example illustrates what I just talked about. So you can have a web browser. It could be a Firefox. But the Firefox web browser will run on any laptop. It will run on HP, it will run on Linux, it will run on a Lenovo laptop. And then those laptops can connect to a Cisco network, or they could connect maybe to a Fortinet network. So what I'm trying to explain right now, and after that, they can traverse the internet and connect to a browser running Apache on a Linux server. So you have, for instance, I can use my Windows laptop. I fire up PuTTY, and using PuTTY, I can go and connect to a Linux machine. But guess what? I'm on a Linux, or I'm on a Windows machine. I don't have to be on a Linux machine to be able to connect to a Linux server. So you find that all these, that interoperability is whereby you have these devices from different vendors, or these different applications from different vendors being able to work together. And before that, like I told you guys, it used to be an issue, a very big issue in the past, which is not a very huge issue right now, because all these vendors, this is made possible and simple because of the OSI model. All right, guys, so this is the OSI model, and these are the layers of the OSI model. I feel like today my screen is small, and okay, maybe that's better. Is my screen clear enough for you guys?
Yes.
All right. You so can guys, you can zoom in, zoom out too as well.
All right. Where do I do for the zoom on this right here? Is there someone I have to press?
No, the other one, the other one.
Point expert. Oh.
Yeah, that one. Oh no, that was just a search.
No, this is search.
No, I was saying that one is just a search, but I mean it's pretty clear right now. We can see better there.
Okay.
That's fine. Yeah, that's fine still.
Maybe I'll play around with this later on, and so that the next lecture is more entertaining. All right, guys. So we do have the OSI, the layers of the OSI model right here. So the OSI model is made up of 7 layers. And the first layer in the OSI model is the physical layer. The second is the data link layer. The third is the network, transport layer, session layer, presentation layer, and then application layer. So when you're starting off, you need to find a way of remembering these layers first, because someone will be coming to you and tells you, I think we do have a layer 3 issue on the network. You should be able to know what is a layer 3 issue. You won't be like, okay, all people sleeping through networking don't pass. So which one is that? So the thing is, so this acronym right here, all people sleeping through networking don't pass, can help you remember the 7 layers of the OSI model. So remember, guys, the OSI model gives us the common rules. It gives manufacturers the common protocols based on the layer that devices can communicate with each other, but also as network and system admins, these are important for troubleshooting. So when you're troubleshooting, and for instance, when I lose my internet connectivity, what's the first thing that I'll try to do? What's the first thing that you try to do when you don't have internet? Can someone give me a tip? Like what you do when you don't have an internet? Jervis, can you tell me how
if I don't have connectivity, I'll check if my NIC is enabled.
you check if?
My NIC is enabled.
How would you check if your NIC is enabled?
I will go through the control panel and look for the network and sharing center. And then there I can, change the data settings, and then I can see if it's and then I can see if I am connected to the network from that interface.
All right, so okay, that is okay. Now Jervis just told us how he would go about troubleshooting an issue whereby he doesn't have internet. But if Jervis had knowledge of the OSI model, what would he first do? What's the first layer? What does the first layer tell us? Guys, what do you see here? Physical. So right now, the first step we take is like, okay, do I have my Ethernet plugged in? Do I have Wi-Fi access? So the OSI model gives you a step-by-step troubleshooting methodology that you can use to resolve network-related issues. So that's one of the advantages of the OSI model. You're able to go from one step to another, trying to determine, all right, is it the physical? Is it the data link? Is it the network? Is it the transport layer? Is it the session? Is it the presentation? Or is it just my application that's acting out? So going from one step to another kind of like gives you a step-by-step methodology on how you can go about troubleshooting your network-related issues. And then the other thing is split development and all areas of concern. So an example is an application developer does not need to understand details of the IP and IP routing, like border gateway protocol. The web developer does not need to understand details of copper or fiber cabling residing at layer 1. So layer 7 and layer 1 are separate. So if you're a developer, or like Faith said, she wants to learn Java and go into coding. If you're a developer, you don't need to know how to set up the cabling for your network. You don't need to know how to install servers in a data center. All you have to do is focus on one layer, which is the application, which is the coding, and how data is being displayed on a platform like Facebook. So for instance, if one of you goes ahead and becomes a Facebook developer, the list of your concerns is going to be things about networking. The list of your concerns is going to be like, how do I cable a network or set up an entire network infrastructure? That is not your concern. So the other advantage of the OSI model is the split development or areas of concern, whereby everyone will focus on that area of concern. For instance, if you're an application developer or you need a web developer, all that you need to know is maybe the application, presentation, and session layer. If you're a network admin or engineer, you focus on the physical data link, network, and transport layers. So this helps you to just focus on that area where you have the greatest return and do all that you need to do. So as a web developer, you don't need to know how to do all these 3 parts right here. A good understanding and knowledge will help you, but it's not a must. Guys, any questions? I've been talking a lot. The silence means no, right? No questions.
Yeah, no questions.
All right. All right. So split concentration and determine at which layer the problem exists. Remember, all right, guys, this is just a tip that I wrote down here. I'm using multiple screens, so sometimes I'll be facing a different direction. Don't mind about the direction I'm facing. So guys, one thing that you need to remember is, remember the names and also the layers. That is very important. because sometimes the interviewer will ask you things about what is a layer 3 switch. So when an interviewer asks you such a question, that you need to know, okay, what is layer 3? You need to know that, okay, that's the networking layer. That's where he's asking me about. And what does a layer 3 switch do? So we shall talk about that later when you're doing a bit about switching. So you may maybe someone from the networking, you may hear someone from the networking department saying, okay, we do have a layer 1 issue. So you should know, okay, they're talking about now something physical, maybe something about the cabling, maybe something about maybe the wiring, the actual wiring of the cables that they're talking about. Or it could be something about layer 3. Or it could be the application side where maybe there's a service that's not working, an application where a service is not working and you need to restart that service to resolve the issue. So that is one of the advantages of the OSI model. I already explained this about a split of concentration, where developers don't need to really know what's happening down here on these lower levels of the OSI model, and their concentration usually is up here, where it's all about the development of the application, unless if they're using things like virtual switches or virtual machines nowadays, where you set up your own virtual machine. And also things like Docker, you may need to have some little knowledge of troubleshooting virtual switches and virtual machines. But generally, in the physical world, developers will concentrate on application presentation and session, and the network engineers will focus on the physical, the data link, the network, and the transport layer. All right, guys. So we're going to go through these layers from the application, and then we shall go all the way down to the physical layer. I'm going to give you guys an overview about what happens at each layer. And after this class, I need you guys to go through the video on networking, the networking videos on the Google Drive and Slack about the different layers and what happens there. So application layer. So this provides network processes to applications. It provides access for users and applications to use network processes. So another way of saying it provides network services to applications. For example, FTP, Telnet, HTTP. So applications, the applications that you use right here, some of them are PuTTY, Firefox, and Chrome. So layer 7 application use protocols to communicate with the lower layers of the OSI model. Guys, does that make sense? Yes or no?
Yeah. Could you please explain it again?
All right. So at this layer, we do have examples like applications like FTP, Telnet, and HTTP, right?
Mm-hmm.
You guys have seen those applications before, right? Yes, you know.
And I know HTTP, the web application, the web.
Yes.
But I don't know about the Telnet and the FTP.
Okay, this is a file transfer protocol.
Oh, okay, yeah.
Okay, that's just an example of file. But okay, let's assume any other applications that you may know that need. All right, I'm speaking to you guys like you are you are Linux admins or in the IT field. That's my problem right now. All right, you guys know HTTP or the web servers. You can go and say google.com and something displays on your browser, right?
Yes, sir.
So those applications need access to the network, right?
Yes.
They need access to the internet. At what layer does that happen? And how do those applications have access to the internet? That is through the application layer. So the application layer has protocols that give users and applications access to the network services or the network processes that help in connectivity. Guys, if you don't understand it, let me know. If you're going to keep quiet through it, later on you have lots of questions. So that's the application layer. That's the layer 7. If you need a different explanation, Jared can chip in and Kingsley can chip in and give you a different perspective. So make sure you don't keep quiet, because if you need a different explanation or a different perspective, you can always ask for that, and we can always give you that.
Okay, I think I have a question. For your phone, when you're using an application.
Who is talking?
Is Ebenezer.
Ebenezer.
With your phone, when you download an application or with the application that comes with the phone, what example, as you see with the HTTP, telnet, FTP, what application layer is it using to work?
All right, for instance, Google, for instance, let me say you download google.com, right? I mean the Google Chrome application, right?
Okay.
So what does Google Chrome use to access the internet?
And that's my question.
So Google Chrome uses HTTP, right?
Okay.
To access the internet. So the application layer uses the HTTP hypertext transfer protocol to help the Google Chrome app that you have downloaded to access the network resources or network processes that will help you connect to the internet. So that's the application. Actually, thanks a lot for asking that question, because I think it even clarifies this more. So because now Chrome will use this protocol right here, hypertext transfer protocol, to help you connect to the internet. So Chrome is the application at this application layer. But Chrome is using HTTP hypertext transfer protocol to help you connect to the internet. That means it's helping you, or this layer is providing you with network. It provides network processes to
add to what Charles is saying. When it comes to application layer, right? You guys should think about it as if it's used to transfer. It's a protocol that gives us it's like a link, like a bridge. It goes like a bridge. That means it controls the traffic of data flowing through the internet and your computer or your cell phone or whatever device. You should look at the application layer as like that. So like you see how it says file transfer protocol. Those are one of the applications, HTTPS. All those are all internet application programs. But for you to get that traffic, for you to get free flow of traffic without interruption or conflict on your internet and your computer, you use the application layer. It controls the flow of traffic. It controls the data that's coming in. It controls the data that's going out. It knows that this data has to take this route. This other data has to take this route. You guys understand what I'm trying to say? So you look at application layer to be like that. So he does like the most of like like, okay, let's say for instance, you go like you have like a border going to another country, or like a border that links you to different countries. If you're trying to go to, let's say, Canada, you know that you have to take this route to get to Canada. If you're trying to go to Europe, you know that you have to take this route to get to Europe. Or you can take it, for example, like when you have at the airport, you know what they call the control tower at the airport? Application layer is just like the control tower. So he controls every plane that's going to what destination and show you the route that you need to take to get to that destination. So it controls the flow of data coming from the internet to your computer and your computer back to the internet. Thank you, Charles.
Thank you. And to try and tie it together with something that might have been taught in the past, where would the DHCP server fall into this as what part of the layer when it's providing internet? It's translating that Google.com using the HTTP application layer. How does then the DHCP server come into play? What layer would the DHCP server fall into?
Not to get you confused, DHCP servers manage your IP addresses, not the flow of traffic. DHCP servers manage your IP addresses, not your flow of traffic. Yes, we can hear you, Bismarck.
Thank you. I think that I equally had the same problem my co-learner is having, but that the problem was clarified when I went into some extensive studies in the Linux. Actually, HTTP stands for Hypertext Transfer Protocol. It actually comes like a packet, which is a daemon, Hypertext Transfer Protocol daemon, and it is a package that we actually install. It actually has a port that it listens to, and he will go into the detailed explanation of how we'll see how we'll configure an HTTP server when we'll be doing Linux with Mr. Gerard, and you actually see it clear. But for the purpose of this, he's just trying to explain how what the application HTTP does at the level of the application layer. But we cannot see the port 443 right now because we are not configuring it. When we're doing HTTP in Linux, you actually see it crystal clear there. Thank you.
All right. Guys, I want you guys to ask questions so that we can get more clarification, because right now I could say maybe, Jervis, can you explain to me the concept of the application layer and how it works? What would you say if an interviewer asks you that from what you've learned right now? How would you go about answering that question? Jervis?
Yeah, I'm here. From what I've gotten so far, I know that the application layer is the interface we see, and it has specific protocols which it works with, such as HTTP, FTP, and DNS too.
Okay. So what do you find at the application layer?
At the application layer, for example, if you go to Google's,
right? We do
yeah,
have
you find applications. Yeah.
Yep, sure. So that's it, guys. At the application layer, we do have applications. And we do, remember, what's the use of the OSI model? Is to provide a standard, right? Is to provide a protocol. So we do have, at each layer, we do have certain protocols that work at that layer. You guys get that part? Yes? So one, we do have applications at layer 7. But at the same time, we do have protocols that work within that layer 7. And those protocols, and remember, guys, we said protocols are a set of rules, right? And those set of rules are going to determine how traffic or how data is routed at that layer. And for this example, use Google Chrome. Someone talked about Chrome. So we used Google Chrome as an example of an application that someone installed on their either phone or their computer. But how is this Chrome right here going to have access to the network processes? It's going to do that through a certain protocol, through a certain rule, because we need all these applications to adhere to a certain rule. So if it's a web-based application or an application that's going to interface with the web, guess what it's going to use? Hypertext Transfer Protocol. A protocol is a rule, and this application right here is going to use this HTTP to have access to the network processes. Guys, that makes sense?
Yes, but if you could take it all over, please, I really beg you.
Who is that, Bismarck?
But I just wish that you come once again.
All right, guys. All right. layer 7 is application layer. And we said at application layer, what do we find application layer? Applications. And we gave examples of those applications. In this case, I said, okay, Party is one of the applications. You're going to use that. Firefox is one of those. Chrome is one of those applications. You guys have not yet done SSH, so I won't use SSH for Party, but let me use Chrome because you are used to Chrome. So we do have these applications right here at the application layer. And we say the OS model concerns itself with setting a standard, a set of rules. And based on these rules, that's how these applications are going to communicate with the environment. That's how these applications are going to have access to network processes. So Chrome right here is going to use a certain rule. Because we say the OSI model has rules at every state, at every layer. So at layer 7, some of the protocols are FTP, Telnet, HTTP. So for HTTP, Chrome is going to use this protocol right here. And this could not be Chrome, this could be Firefox. Firefox is also a web-facing application. Firefox is also going to use HTTP. So guys, do you see why the OSI model is important? The Firefox people didn't come up with their own protocol. The Chrome people did not come up with their own protocol. There's a standard protocol that they use based on the OSI model. And this protocol, based on this layer, is the HTTP protocol. So Firefox, different vendor. Chrome, different company. But guess what? They're both using the same protocol, HTTP. And the protocol is a rule. So they're both using the same rule to access network processes, the same rule, HTTP, to access the internet. So Firefox didn't go ahead and make their own protocol on how they how Firefox should access the web resources. Chrome did not come up with their own protocol. The OSI, the Organization for Standardization Organization for the Standardization of all these protocols came up with this. And now all these guys at Firefox are using that. Chrome is using HTTP. Internet Explorer is using HTTP. So all these guys are using the same protocol to access network processes.
Okay, sir, thank you, but having one small question, please, but it's baffling. Please, it's short. So can I say that the port that Chrome and Firefox that communicate will listen to the same port over HTTP?
Yes, but
thank you.
Yes, but I don't want to take people into ports right now. But yes,
I understand. That's why I was saying that.
That is true. All right, guys. The next layer. At what time are we finishing today? Gerard, are you there?
I think we're already above time already.
Yeah, I think we are right at the mark, and we are like even 5 or 6 minutes over. But if you can just take us through the presentation layer real quick, we can wrap it up for today.
All right, guys, presentation, how something is presented to you. So this layer concerns itself with the actual format data is presented. So it's about data presentation and data syntax. So it ensures that data that is sent by one application is readable by the receiving application. So this layer formats data to be presented to the application layer. It structures, the presentation layer structures that data. Another way of saying that, you guys, is it negotiates data transfer syntax for the application layer. So this is the more of the technical term. This formats data to be presented to the application layer is like the layman's term. So this will help you understand. But when you're answering, for instance, in an interview, you may say it negotiates data transfer syntax for the application layer. And the interview will be like, okay, he knows what he's talking about. So the presentation layer also encrypts provides encryption for the data. So it ensures that data is presented in a format that both sides understand. For example, Linux and Windows. Linux, Mac, and Windows format data differently. Data needs to be changed to machine independent format. So for instance, guys, I may have a JPEG file. What does JPEG open?
Pictures.
It opens pictures. Good.
Pictures.
Yeah. So when I'm in my Windows, I can open up a JPEG, right?
Yes.
But when I go to a Mac, can I open up a JPEG in Mac?
I think yes. Right.
Yes. Yes, I can open up a JPEG in Mac. So can I use Notepad to open up JPEG because I'm in Windows?
No, Notepad.
I cannot use Notepad. Has someone ever tried to use Notepad to open up a JPEG file? All right, can you use Notepad to open up an MP3 file?
No.
I think the
Why?
The file types, when you look at the extension of the name, I think it gives us a hint as to how it can be opened up or what we are to expect when we open up the file.
For some reason, your audio is not coming out well. It seems like a big echo in the background, like everyone else, I can hear you well, apart from the person who was just speaking previously.
I can try and type it in chat if I can help, but I was saying the file extension is maybe giving us a clue as to what to expect.
Gerard, did you hear what I said?
I think his headphone is giving issues. We really can't hear him.
Can you type what you're saying? So there is a lot of echo coming from your side, so we really can't hear you.
All right, guys. As it types that, do you guys have a general idea of about the presentation layer is? So it formats data in a language that type for instance, if I send a file from Linux to my Windows machine, when I receive that file on my Windows machine and I open it up, the presentation layer makes sure that the format which that file was sent from Linux to my Windows machine can be opened up in my Windows machine. So the presentation layer is about formatting the data into a format that can be read by Windows, even though that data is from a Linux machine. So if it's an audio file from Linux and I send that audio file to my Windows, I will receive it as an audio file, and I will be able to open it up as an audio file on Windows. Questions, silence. Let me see someone in the chat. Any questions? Guys, any questions about the presentation layer?
Not from my
Not too
end.
much.
Can you please repeat one more time? I didn't understand very well this one.
Gerard, are you going to give out the video?
Videos are available 1 hour after class. So so the video of yesterday, I said I was gonna put it up 1 hour after class, and I did that. And same with any other video. So after an hour, this video is gonna be available. But I think Mr. Barry just wants you to explain the presentation layer again, so he can actually understand. So,
all right, guys, presentation, how data is formatted. So let me try to see if I can get another way of explaining it different from what I already said. So when I do have it's just going to be verbatim. I'm just going to use the same words over and over again. So guys, so in summary, what you need to know about the presentation layer, it's all about the formatting of the data. And the data is formatted based on the application. For instance, a Word document will have a different format from a music file. A music file will have a different format from a zipped file. And that will have a different format, maybe from another file that has been tarred in a different way. So that's what the presentation layer is. It's all about formatting the data. So if I'm receiving a music file on my machine, it won't be presented as an maybe a Word document, even though it came from, if I'm receiving it on a Linux machine from a Windows, when a music machine MP3 file is sent over, I want to receive it as a Windows, as a Word document. I receive it in the same format as a music file, and that is taken care of in the presentation layer, where the data is received in the format that is readable by the receiving application. So that is what the presentation layer does.
Thank you.
I need you guys to go through the videos. When you go through the videos again and you listen to this, it will make way more sense. So this week, make sure you go through the entire OSI model so that you get a good picture of how it works. So that when I'm explaining all these concepts, we can have a back and forth conversation whereby you guys can ask intelligent questions. By intelligent means you guys have gone through the videos and you understand and you have an overview of how this works, so that we just kind of like chatting about things that you guys have read about and have watched and and are finding interesting, or things that you may need more clarification about. So this week, make sure you get grounded in the OSI model. If it means going over it 7 times, go over it 7 times till you understand it in and out. And next week, I'll make sure we do have a quiz and interview about the OSI model. Each person just get ready for an interview question this coming week on the OSI model.
Before you round off, yeah, just one, please. Sometimes do the developers or the network engineers ensure that sometimes they are able to meet the filament, I mean the separation between layer 6 and layer 7 is so thin that sometimes they interchange. Sometimes instead of a network engineer using layer 6 for encryption, they instead go and use the level 7. How possible can a network engineer make it?
How possible can? What do you mean encryption at layer 7?
Explanation you've given is made understood that encryption and decryption, in fact encoding of data, is made possible at layer 6, which
Yeah.
is a presentation layer. But I was asking because I have seen scenarios, especially on the data, where an explanation was given, but I didn't get it clearly how that is possible for um, for encoding encryption to be made possible instead in layer 7, and that you can take the application of HTTP in layer 7 and present it in layer 6. I don't know how those networking engineers are interchanging the layers, especially at a higher level like that.
Gerard, do you understand that question?
Well, I don't quite
Okay,
get it,
please
but
let me try to put the question in another way. When I understand it, maybe I am confused the way I'm putting it. That's why people don't get it. So just give me the whole of till Wednesday, and then I'll put the question in the way that you can understand. Because right now I'm instead. Thank you.
Okay.
All right, sure. Yeah, just drop it in the Slack, and maybe Gerard, I'm not sure about Wednesday if I can sit in because
No, I'll be there. Don't worry about Wednesday.
right.
Wednesday is just a chit chat class and just catching up, taking questions and all that. So if you can make it, that's fine. Kingsley and myself are gonna be there. So thank you for this wonderful session, Mr. Charles. You can stop sharing, and I'll stop recording right now.
Jared, please, yep, take over.
Yes. So I just want to thank you guys. I know we've gone almost 20 minutes above time, and I do apologize for that. And thank you, Charles, for doing a wonderful job. I think it was a very, very productive session. And I want to thank all of you, Cesar. Thanks for making the sacrifice. Bismarck, always keeping the class lively. Emeka, thanks so much. Jonathan, Jarvis, Ebenezer, Ola, you all, Mr. Barry, thanks so much for spending this time. One thing is the sacrifice that we make today that's going to pay off tomorrow, and I do believe it's going to pay off. We are not expecting that everything that we're teaching you guys are going to grasp right away. It's a slow process, and with time you guys are going to become comfortable. But to get to that level of comfort, we also need effort from your side. So create the time. I will recommend that you go through this video again, watch this video again after class, watch the video of yesterday's class, because as the videos keep piling up and as the concepts keep piling up, you start forgetting the ones in the past. And you don't want to do that, because you need to take what you learn and apply as we move along. So don't just take something that we did like 4 classes ago and like, okay, we already did that, I forgot about it. It's about now. What are we doing right now? So we're gonna be applying these concepts as we go along. So always, I really applaud the efforts you guys are making. You guys are putting. Like I said, it's a slow process, but we're gonna build together and let's work. Let's take this journey together, holding each other's arms. It's not gonna be easy, but let's all put in that effort together and work together. Your next job is out there staring at you, and even if you're already making 100K right now, it never hurts to make an extra 100K on the side, right? If you don't need it, please get it for me. I'll do the job. So thanks once again for staying back and having this session. And again, guys, understanding the OSI model is key. If there is anything you should understand in networking, guys, it's not IP addresses, it's not routers and switches. It's understanding the OSI model. So please spend some time, go through the. I think Professor Messer in the video, he really spoke about the OSI model, but don't end there. Google the OSI model, read more about it, go to YouTube, get other people's explanations, because you can listen to one person and he explains something and it's not really clear to you. Find out like, okay, let me see what this other person says, right? So you get it from different people, and you're gonna finally get it from someone that actually makes sense to you. So listen to different people explain this OSI model and try to understand it, because your understanding of the OSI model is key to your understanding of IT. Everything that encapsulates communication, we communicating right now, is thanks to the OSI model. And as IT professionals, we should be able to explain what happens when data leaves my network and goes to your network. We should be able to understand that process from the application level all the way to the physical level and back to the receiving person's physical level, back and up to the application level. We should be able to understand this and explain it, because when you guys start the interview process, that's where they're going to start. They're not going to ask you what is a computer. They'll start with networking. They start with networking, and OSI does not lack. There's no way you escape it in an interview. So spend time on it. Even if you are not getting it, spend more time on it. Bring questions, ask questions, and you get it. I promise you. So once more, thanks again. And we'll take any other question, general question, just general comments, and then I'll let you guys go and have fun and enjoy the rest of your day. And I had a question. Two people reached out to me yesterday. They were asking me on the class payment plan, and they wanted to make their payments. So usually we do payments based on your payment plan that you agreed with TechSpace, and based on the down payment that you put in. You know, some people put in more than the required down payment. Some people put in just the required. So payment plans are structured based on what you put down. So when it's time for you to make any payment, you just need to go look at the payment plan that you agreed with us, and you know how much you are supposed to pay for the month. So normally the payment due date for this month is the 27th. So by Saturday the 27th, everybody's supposed to have made in their payments for the month. So which means from now, if you want to do your payment, you're free to do it. But 27th is the deadline to make your payment for the month. And if your payment doesn't come in on time, you most probably lose class access. And I hate doing that. We hate doing that. We don't want we don't interrupt anybody's studies. So if you want to do your payment in advance, fine and good. But 27th is the deadline, and I will send out a message beginning next week or the week after, so I don't catch people by surprise. You know, it's always good to give advance notice so people start getting ready. Otherwise, thank you, Jarvis, for finishing up your payment. You know, I appreciate that. So any other comments we'll take, and at this point I'll stop recording. But the class is open for comments.